Hello guys, today we're going to be talking about how to do the Euclidean theorem. It's basically another way to factor. I kind of think of it like a hack to factoring because without all the prime factorization I can never get the factors right. So to explain this, I'm going to start off with a super easy example. 12 and 18. It's really simple and I bet a bunch of you could just go like this. 2, 3, and then 18 is 2, 9, 3, 3, and you can easily tell that 6 is the GCF. But, GCF, okay. The Euclidean theorem is another way to figure this out, except for more complicated numbers, it's much easier. For numbers like these, which you can tell right off the bat, it's a little more work. Alright, so how we're going to do this, you try to find the amount of times that the first number can go into the second number. So I like to write the smaller number first and then the second number second. So this is just for two numbers, the one we're learning now. So you put the smaller number first and then the second number, and then you try to see how many times can the smaller number go into the second number and what is the remainder. So 12, as you guys know, can go into 18 once, and then you'd have a remainder of 6. So you'd keep 12 here, but this is really important. Instead of keeping 18, you put the remainder that you just found, 6. The number doesn't matter, so if 12 went in 2 times, you do nothing with that number. That number does not matter. And so 12 and 6. And now, how many times does 6 go into 12, and what's the remainder? Well, it's obvious, 6 goes into 12 twice, and then 12 minus 12 equals 0. So there's no remainder. So you write 0, 6. And once you get to this stage, where one of the numbers is 0, the other number is going to be the GCF. So here, 6 is going to be our GCF. So that was a pretty easy example and took 3 steps. So now I'm going to go on to a little bit of a more difficult example. 108 and 144. So we're going to start by figuring it out the factoring way to make this, work both ways. 9 and 12, 3 and 3, 2, 2, 3, and then 144 is 12 and 12, 2, 2, 3, 2, 2, 3. This would be 2 squared times 3 cubed, and then 2 to the 4th times 3 squared. Oops, that did not work. And so with this, you can easily tell 2 squared times 3 squared. This is going to be your GCF, 4 times 9, which equals 36. So our GCF with these two is going to be 36. We've figured that out from factoring. And now we're going to try to do it with the Euclidean theorem. So 108. And then how many times will it go into 144? It's fairly obvious that it'll go into 144 one time. And then you'll get 36 from that. And now how many times does it go into 108? We can do 36 times 3, which will equate to 108 entirely. So then you'd have 0 as the remainder here, because since 36 went into 108 3 times, which does not matter. Just the important thing is that it went in evenly. So the remainder is 0, which would mean that over here, it'd be 0 and 36, which means that 36 will be your GCF. So now I'm going to go on to another example. 36 and 162. So 36, we know, is 2 squared times 3 squared. 162 is 2 times 81, which is 9 times 9, which is 3 times 3. Well, for both 9, so 2 times 3 to the 4th, and 2 squared times 3 squared. We know from factoring the prime factorization method that 2 times 3 squared is going to be your GCF. 2 times 9 equals 18. So now we're going to try to see if we can find it from here. So 36, how many times is 36 going to go into 162? About 4 or 5. So I'm going to try 4 first. 44, and then 162 minus 144 is going to be more than 36. So it's not going to go in 5 times. So we'll just do this. So now we know 18 is the remainder, which, once again, we know 18 goes into 36 twice with the remainder of 0. So we'll have 0 here and 18 here. Okay, so these were simpler methods now, and these were pre-picked problems. Now I'm going to pick a couple of random numbers and see if we can use those and also achieve similar results. Okay, so I'm just going to pick 176 and 632, just because why not? And so I'm not going to do the factoring method here. We're just going to do it straight Euclidean algorithm, or theorem. And so first we can try, how many times does 176 go into 632? I will try the number 3, because why not? 18, carry over the 1, 22, 5, 528. 528 plus 176 is going to be more than 632, which means that 176 times 4 will be more than 632, which we can see right here. It'll be 704. So that's more than 632, so we'll stick with this one. Just remember that 3 does not matter. It just doesn't matter in this case. So 632 minus 528 is 104. So now we're going to put 176 and 104. I recommend that you write each step out like this, even though it might take a lot of space and a lot of time. But if you try skipping steps, you might get mixed up, and if you get mixed up, then it's not going to help. So now how many times does 104 go in 176? It obviously goes in once, and 176 minus 104 is 72. So this would be 72 and 104. Now, how many times does 72 go into 104, and what's the remainder? So 72 goes into 144 if you multiply it by 2. So 72 times 2 equals 144. Therefore, 72 times 1 will be in 104. So 104 minus 72, 2, 3. So 32. 72 and 32. Now, how many times does 32 go into 72? We know it goes twice because 32 times 2 is 64. So we'll just subtract 72 minus 64, which equals 8. So now we have 8 and 32. Now, right off the bat here, we can see that 8 goes into 32. But just in case you get some bigger numbers whose multiples you aren't aware of, like you don't know what 176 times 3 is, which we have right here. Say your last numbers are 176 and 528. You're probably not able to see that right off the bat, so I would recommend going through with the step just in preparation for harder problems if you ever get them. So 8 times 4 is 8 times 4 is 32, and 32 minus 32 equals 0. So we'll write out 8 and 0 here, and from here, since one of the numbers is 0, we know the other number is our answer, 8. So I think I can try another problem here. We can choose 281 and 538. Why not? So how many times does 281 go into 538? 281 times 2 equals 562. And that's clearly larger, so it's only going to go in once. So we're going to subtract 538 minus 281 and get 7, 13, 5, 2. 281, 257. So this is just a little note that might be of use. You know that you've done the multiplication and subtraction wrong if the second number is greater than the first after the first step, because that means that the first number can go in another time. For example, if we have, say, 3 and 8, and then we can't tell that 3 goes into 8 twice. So this is just a silly example, but so we'll say it goes in once. So a minus 3 is 5. So 3 and 5. You know that 5 is larger than 3. You can tell. So you know that you messed up, that it's going to go in at least one more time if it says, yeah. So you know it's going to go in at least one more time. So what you could do the same step again, except since you can't do larger into smaller, you can do it again from first to second. So you can try again, 5 minus 3 is 2. That's one thing if you don't find the exact multiple, but anyways, I'm just saying. If this second number is greater than the first after the first step, then you know that you've messed something up. Okay, so back to this problem. So how many times does 257 go into 281? So we can find that 257 goes into 281 once. Minus 257 equals 11, 4, 7, 2. And then these will cancel out. So it goes in 24. Or not. It leaves a remainder of 24. How many times does 24 go into 257? So I can see that 24 times 10 is going to be 240. So I'm just going to go with that. 240. And since 257, and then we can try 24 by 11. 4, 2, 0, 4, 2, 264, which is greater than 257. So we're going to do, right here, let's make some space. 257 minus 240 equals 17. So now we know our remainder is 17. So 24 and 17. And now how many times does 17 go into 284 and what's the remainder? It goes in once. And 24 minus 17 equals 7. So 7 and 17. Yeah, so here we, okay, so this is the remainder, and now we try it a backwards way. So, sorry. Now we try again. 7 to 17 this time. How many times does 7 go into 17? We know it goes twice because 7 times 2 is 14. So 17 minus 14 equals 3. So now that our remainder is 3, we're going to write a 7 here and 3 here. Now, most of you can tell this right off the bat, but we'll keep going. I'm just going to keep going through it for example's sake. But so how many times does 3 go into 7? 2 times with the remainder of 1 because 7 minus 6 is 1. So we have 1 and 3. How many times does 1 go into 3? Okay, so right off the bat here, actually I'll say this after this example. How many times does 1 go into 3? 1 goes into 3 3 times, which leaves a remainder of 0 because 3 minus 3 is 0. This is 0, 1. So you know that 1 is your GCF, which means that these two numbers are actually relatively prime. The largest factor they share is 1. So when you get to a step like this where 1 is in your answer, or if you already have two relatively prime numbers that you know, like we know 3 and 7 are relatively prime. So once you have that, once you get to one of these steps, you know that 1 is going to be the greatest common factor, and that, yeah, they're good. The numbers are going to be relatively prime. So thank you for watching this video. If you have any questions on how to do this, please comment them below, and also comment what you want to see next.